Hello, everyone. Thanks for joining this session. And Chief AI Officer program, as part of this, today I will be covering AI model development life cycle and, from data gathering to AI model deployment, and then model training, validation, and scaling AI systems, and AI model monitoring, retaining, and feedback loops. As part of this AI model development lifecycle, and, uh, and the AI model development lifecycle is critical and crucial and critical framework for successful building, deploying, and maintaining AI models in business environment. For a chief AI officer, understanding the complete life cycle from ideation to deployment and continuous monitoring is essential for maximizing the impact of AI investments. This module provides a deep dive into stages of AI model development and life cycle, including problem definition, data collection and preparation, model selection and training, evaluation and deployment and monitoring. It also explores best practices for managing this life cycle to ensure that AI models are efficiently ethical and aligned with organization goals. As part of this life cycle, first one is as you know, problem definition and scoping, identifying business problem for AI, understanding how to define a clear business problem that AI solve, and conducting needs necessary to align AI project with organizational goals, such as increasing efficiency, improving customer experience, and driving innovation. For formulating AI use cases, translating business challenges into specific AI use cases, such as predictive management, predictive maintenance, fraud detection, then customer segmentation or personalized recommendation. Scoping the problem to ensure it is feasible, measurable, and aligned with the business objective. Defining success metrics, establishing clear metrics and KPIs, key process indicators, to measure the success of AI models, determining how the AI solution will create value for business, such as reducing cost, increasing revenue, or improving customer satisfaction. Data collection and preparation, data gathering for AI models, identifying relevant data sources and collecting data required to train AI models, gathering both structured and unstructured data, ensuring the right data type are used to address the specific problem. Data preparation and cleaning, in, techniques for cleaning data to remove inconsistency, missing value, outliers, and noise. Standardizing and transforming data into format suitable for training AI models, including data normalization, scaling, and encoding. Features engineering and selection, extracting relevant features for raw data to improve uh, accuracy of AI model, selecting most informative features through features uh, selection techniques to optimize model performance. Then comes data augmentation using techniques such as synthetic data generation and data augmentation to expand training data set, and particularly for tasks like computer vision and natural language processing. Then comes model selection and development. Choosing the right algorithm, understanding the strength and limitation of various AI algorithms, including machine learning and deep learning models. Selection algorithm based on type of data, problem complexity, and desired outcomes. Common algorithm includes regression and classification, clustering, decision tree, neural network, uh, and enable methods. Model training AI models using prepared dataset and selected algorithm, selecting hyperparameters, tuning models for better performance, and evaluating models during in the training process. Cross validation and hyperparameter tuning using techniques like k-fold held cross validation to avoid overfitting and ensuring model generation. Hyperparameter tuning using methods like grid search, random search, and Bayesian optimization to optimize model performance. Deep learning and neural network. Training deep learning models such as convolutional neural network for image classification and or recurrent neural network for sequence data. Understanding the unique challenges and consideration involved in training neural network. Then next stage, as part of this cycle, model evaluation and testing. Evaluation matrix. Choosing the right evaluation matrix based on the business problem and model type. Understanding the trade-off between different metrics, particularly in based of imbalanced data set. Model validation using techniques such as cross validation, hold out validation, and testing with unseen data to access model performance. Identifying issues such as overfitting or underfitting and addressing them through regulation or more data. Bias and fairness evaluation, checking for bias in the AI model by analyzing predictions across different group and ensuring fairness. Applying techniques like fairness, constraint, and adverse adversarial testing to reduce bias in model output. Explaining and interpretability, ensuring the model is interpretable, uh, especially in regulated industries by using techniques such as sharp, that is shapely, uh, additive explanations, and lime, local interpretable model agnostic explanations. Communication model result in a way that is understandable to non-technical stakeholders. Model deployment strategies decide on the deployment strategies such as batch processing versus real-time inference, cloud-based versus on-premises deployment, or deploying an edge device for edge AI applications. Preparing the model for integration with business system and ensuring compatibility and with the existing IT infrastructure. Model containerization and CI/CD using containerization tools like Docker to package the model for deployment. Implementing continuous integration and continuous deployment pipeline to automate the model deployment process and ensure efficient and updates. Scalability and performance, ensuring the model is scalable to handle increased amount of data or users. Monitoring and optimizing model performance to ensure it can meet real-time damage if required. Security and compliance in deployment, addressing security concern in AI model deployment, including in securing sensitive data, preventing adversarial attacks, and ensuring regulatory compliance in industries like healthcare and finance. Then comes model monitoring and maintenance. Model monitoring, continuously monitoring model performance in real world to identify issues such as model drift, data drift, if the for performance degradation. Then model retraining, regularly retaining the model with the new data to ensure it uh, remains accurate and relevant. Managing model lifecycle, tracking model through their lifecycle from from development to deployment to to retirement. Ensuring ethical and responsible AI, it continuous evaluating the ethical impact of deployed models, ensuring they comply with fairness, transparency, and accountability standards. Then comes scaling AI model, scale model for large data set, handling large volume of data in AI application, ensuring the model can scale efficiently to process and analyze data in a timely manner. Using distributed computing platform like Apache Spark, Kubernetes, and cloud-based solution to scale AI world workload. Then comes real-time AI, edge AI. Deploying AI model in a real-time environment, ensuring fast decision-making capability in applications like autonomous driving, robot, and fraud detection. Continuous improvement and feedback loop, incorporating user feedback, creating feedback loop that allows user interaction to improve model performance, collecting feedback on prediction or recommendation to refine the AI system over time. Then comes model auditing and compliance, ensuring ongoing audits are compliant with data privacy regulation and ethical guidelines, creating transparency reports and documentation for regulatory or public scrutiny. In nutshell, developing a comprehensive understanding of stage involved in AI model development lifecycle, from problem definition to deployment and monitoring. Learn how to uh, select the appropriate data set, data and algorithm for AI models, and gain a hands-on experience with the model training, evaluation, and optimization. Understanding best practice for deploying and scaling AI models in real world business environment, ensuring the model meet the performance, security, and compliance standard. Gain insight into how to uh, monitor and maintain AI model, ensuring that they remain effective and relevant in dynamic business context. Then comes cloud and AI infrastructure. Under this, so typically, I would be going in detail about the cloud computing fundamentals, overview of cloud computing, understanding the basic principles of cloud computing, including the difference in the service models, infrastructure as a service, then software as a service, then platform as a service. Cloud deployment models, exploring public, private, hybrid models, and understanding when to use each of AI project. Then comes cloud service for AI, exploring cloud services and platform specifically designed for AI, such as Google AI platform, AWS, uh, Sage Marker, SageMaker, Microsoft Azure AI, and IBM Watson. Cloud architecture for AI, designing a cloud architecture for that supports AI workloads. Then comes AI infrastructure design, AI compute infrastructure, identifying computing power required for training AI model. Then scalable infrastructure for AI, building an elastic and scalable infrastructure that can dynamically scale up down based on the computation and demand of AI workloads. Storage solution for AI, understanding the need for different types of storage solution for AI, such as block storage, object storage, and file storage based on the data requirement. High performance computing, leveraging HPC cluster for AI model deployment with the required massive parallel processing. Exploring HPC in the cloud can be used for complex AI tasks like deep learning model training. Then comes data management in cloud for AI. So usually data lake versus data warehouse, the data pipelines and ETL in cloud data security and privacy. Cloud-based machine learning platform, managed machine learning platform, and auto ML, automated machine learnings, then model training and tuning in the model in the cloud, model training and tuning the cloud, AI in model deployment, Then comes the AI model deployment in cloud, deploying AI model at scale, continuous deployment and CI/CD for AI, monitoring deployment AI model, and cost management and optimization of cloud AI, cost implication of cloud AI, and optimizing cloud AI cost, resource allocation and right sizing, AI on edge and hybrid cloud deployment, edge AI deployment, then hybrid cloud AI. And then comes security and compliance in cloud-based AI, ensuring secure AI workloads, then cloud compliance and data privacy. AI infrastructure for collaboration and version control, collaboration tools for AI teams, and version control for AI models. Using cloud-based collaboration platform for Google Colab, Jupyter Notebook, and on cloud Azure notebooks for shared model deployment and experimentations. Leverage cloud storage solution like AWS S3 and Google Cloud Storage to ensure easy collaboration on large database. Version control for AI model, implementing version control practice for AI models and dataset using like D, DWC, the data version and control, and Git, ensuring approaches and ensuring productivity for AI experiments and by tracing model code parameters and data set across deployment cycle. In nutshell, gain an in-depth understanding of cloud computing principles, infrastructure, and services is especially tailored for AI workloads. Learn how to design and deploy scalable AI infrastructure on cloud platform, ensuring optimal performance, cost efficiency, and security. Master cloud-based machine learning platform, AutoML tool, and how to leverage cloud resource to distribute model training and deployment. Understanding complexity of management in cloud-based AI environment, and learn strategies to optimize resource allocation and minimize cloud expenses. Understanding how to deploy AI models at a scale in the cloud and manage full lifecycle from model deployment to real-time inference. So that's about the about this session. Thanks for joining. Thank you.